most of the strangers are at the moment. So this is Grapple 2023, and this year the group was. Are you good, Sam?
No, it's not working.
Okay, just talking to.
Do you know what to do? It should be working.
Can you see anything, Colin?
No.
Can you go to the video?
It's doing something. No, sorry, it should be working. It's working. Like this. Like,
You got something?
yeah, it's actually right.
Oh, the camera turned itself off. I don't know.
Look over to this one and see if you can see. So, it's up there.
Has the camera got anything on the screen? Yep. You see? No.
Yeah, back again.
Sorry, Christian. Okay, cool. I think we're good to go. All right, so this is Grapple 2023. Can't see me? And so this year we've got 2 weeks, but this first week we've got 20 people from as far north as Pattaya, sweet, and as far south as. And so everyone's flown here for the week, and they are spending their time either in their hotel room, but probably mostly in this room, working on an engineering problem to do with life on Mars. So everyone here knows the challenge, but for people watching at home, a really short thing is a situation about life on Mars, and they're making a product or something to improve life for a small colony on Mars. We've got 4 groups, and they will come up and give you the idea for 10 minutes, and the judges will ask some questions, and then we'll go into judging. Cool. What I might do is just go a quick round of our judges, just so they can introduce themselves and what they do for our participants. Cool. We'll start with you, Sina, if that's all right.
I'm what's called a civil engineer, so I'm not really up to date with all the IT and gov stuff that you guys are working on. But I'm an engineer with 20 years experience in the industry, most of my work is in infrastructure, and really excited to be here and hear what you guys are doing today.
Hi everyone, I'm Selena. I'm a 4th year engineering student studying electrical at UC. I know Clark, he was my old high school teacher. When I was in high school, I did weekend challenges like these. I always found it really fun, so I'm really excited to see what everyone's kind of.
I'm Ewan. I'm thinking about more facilities. I've been a little bit involved with the YMCA with the buildings, that's strengthening this building that we're in at the moment, and then also with the building with the new one that's nothing with the YMCA.
Hey guys, I'm Matt. I'm an architect. I actually work for Architectus, which is sponsoring this today. I'm the lead architect on the building that's going up next door. So good to see progress, and look forward to seeing you guys at month this week.
Cool. I'm Ben, a structural engineer at Becca. A big focus on automation and the cultural impact at Becca of how automation changes how we're going to design things in the future.
We'll go through our youth judges, so you can kind of introduce yourselves.
Hi, I'm Sam. I competed last year, and this year I'm back as a mentor.
I also competed last year and I got offered a job
yeah, from that opportunity. So yeah, thank you for it. Yeah.
Tendo and study in mechanical engineering at Lawrence and being done for Grapple last year and this year again. Oh.
Here we have our first group, colon D, or also known as smiley face. Yeah, take it away.
My name's Lee Mayerweda. I'm from Qatar. I didn't know anyone here before coming, and I have a slideshow.
Yeah, my name's Levi Hamweda. I'm from Kirikiri. I didn't know anyone here, and I help with the presentation and the scenario for like behind our product.
I'm Alan. Christchurch, didn't know anyone. Mainly pretty quickly, but.
I'm Francis. I'm from Hawke's Bay. I did all of the laser cutting and organizing and making plans.
Hi, I'm Teakwood. I came all the way down south from Invercargill, and I actually drove Hunter for a couple of months. Yeah.
As you know, schoolmates, so but I go to the LC. I did love a bit of damage for our system.
Okay, so I want you all to imagine the scenario. You're an astronaut. You've just landed on Mars alongside 500 other people, and you're joining a pre-existing colony. 5 years later, you check your ration. You're running critically low. So you're trying to find a way to get a sustainable and nutritious food source.
We found a solution. We created a circular ecosystem that filters water while producing fresh food without the need of soil. This will enable the population to increase on Mars. The underground ice is melted, filtered, then sent to the chicken farm. After a while, the chicken defecate. Chicken manure is then collected and sprayed onto the wheat roots, and the cycle repeats itself.
Microwave, and essentially microwaves shut down big bites to the microwave pipe. That we will have to have like so again. This is where the theory ends, and so I've developed a installation process.
There is an animation clip, but the computer's going, but this
Is the computer off or the
computer on it, just switch it off on the
Okay, do you want to pull the plug out and just put it here maybe? Wow, that's great timing, isn't it? Turn your music down.
Okay, so what's happening here is the vaporized water is coming up through the pipe, and it's going to come up, and we're going to go. It's going to go to our installation capacity, and in there it will be into the distillation tank. And what's going to happen is that there will be a mist of oil that runs cold water through the pipe, and what will happen is that the vaporized water will condense and drop down to the bottom of the tank, and that liquid water will then be stored as when we stored in this tank that can later be pumped to our chicken farm. This is a diagram as well as
Alright. Why we chose chickens? Chicken manure replaces synthetic fertilizer, alternative compound fertilizer. This can consist of 13 major plant nutrients. The major ones being nitrogen, phosphorus, and potassium. Chickens can provide us with fresh eggs, fresh meat that the colony can use and utilize. The shells and the bones can both be mushed up in a blender and then fed back through the system and recycled and help the crop yield, so we can furthermore produce a chicken farm. We chose chickens because our systems offer good opportunities about sustainability, as they are small and compact, and they don't need much room to grow.
The chicken manure is then fed into the roots of our hydroponic system. So hydroponics is a soilless method of growing plants. So we have a sprayer underneath, which spray into the roots of these plants. This allows a lot more efficient. It uses a lot less water, and it also means that we don't need to use any of the soil on Mars, because if we were to use it, then the nutrients in the soil will go into the plants and make it toxic.
So I will be explaining exactly how the system works. So we have the filtration system that she has explained right over here. So that cleans out the water and also gets fresh water from Mars. That water will then be pumped into the system. There is a device here that makes sure that the trough gets filled up to a certain level and it cannot overflow. And there is a timer connected to the sprinkler. So it will only sprinkle certain times during the day. And then all of the chicken manure will then drop down into this catcher, and it will then pump down into the pumps, and the pumps will concentrate it and send it down to the roots. That will then be sprayed onto the roots, and all of the excess water will then come down, drip down, and be sent back to the filter to be reduced. So that way, it's ecosystem. Over here, I'll just explain quickly how the structure might look and a future development it possibly might have. So in these little triangles here, and there would be a paper passed around, that will be the sections where the pumps will be located and where it's possible to clean the pumps, access the chickens, and all of the above. And there's a quick sketch of how it might be developed in the future.
Now with the wastewater, the most sustainable option is to conserve the water and clean it out. And to clean it out. The chicken farm will send the wastewater to our water filter facility, and with that, I'll explain it as it goes. Firstly, the wastewater system will be filtered using a fine screen, and any large matter will be filtered out. And then it will enter the coagulation process, where we'll add aluminum sulfate, and essentially that will bind the waste particles together so that they'll become larger, and then in the coagulation tank that will continue to happen until we get to the clarifying stage, where the larger particles, they will be turned into sludge that will be we turn to sludge that will essentially be piped down, and then the remaining water, it will be sent to our rapid sand filter, where it will be filtered through sand, and that will catch any other impurities, and that clean water will then be pumped back. And then we can disinfect it using chlorine to get rid of any other viruses or bacteria. And then that water is then clean enough to be sent back to our main water supply for our chicken farm. Diagram of how that works going around to.
For the future development of our project that we've created, we have multiple ways that we may be able to improve and expand on this idea. The main and most important part, in my opinion, is that it is easily expandable, both horizontally and vertically, to create more space and provide more food for our area. Not only this, but the basis of this idea can be incorporated to include multiple different types of animals, including pigs, other species of chicken, as well as sheep, cows, and a whole lot more. On top of this, different types of plants can be included, such as carrots, potatoes, and more.
Alright, just before we get into the questions, I'd like to have a quick thank you to the Grapple team and everyone else that's helped, as well as the judges that came today. Yeah, thanks.
Thank you so much.
Okay, let's go. New questions then. What's the little red thing that blinking in the top of it?
This here is the sensor for the water, and so basically how it works is it reads how much water is contacting it. As water is a conductor of electricity, as the water contacts more of this area, it then allows more energy to pass through. We can then read to see how much energy is passing through the sensor to find out how full the water trough is. After a certain level, we will then tell the motor to stop, and once the sensor detects that the water levels have dropped below a certain level, it will then re-enable the pump and fill it back up to maximum volume.
Perfect. And are the chickens free range?
Yes, the chickens are free range. We try to make it as possible closely as you can to Earth, and there shall also be a skylight above, and there is artificial growing lights underneath as well.
What happens if the chickens get sick? Do you have the ability to treat the chicken food before you spray it on the plants?
Definitely, there will be like a system in place to check that as well. That's part of future development as well. So then we'll be able to stop and clear out that water to make sure that water is not contaminating the rest of the field or the crop and everything else above. So there will be regular readers probably in place, but we kind of, a week is not a lot, so yeah, future development. Yes, I think you can. I did a few glasses before.
Let me know when you want it turned on.
Yeah, just that. The plugs just popped out. Sweet, so that should be a bit. Yeah, yeah.
Yeah, I think I got the lighting on. So.
Oh. Yeah, there we go. So as you can see, it is quite dirty compared to your average water.
Yeah.
We represented it with like a little bit of black, so it drags it through.
That's a illustration. Well done, in build. I really like how you introduced all your roles. Because this is very much a team event. How did you guys come about choosing your various roles? Because obviously there's plenty to do. How did that come about? Was it easy? Was it?
Yeah,
Everybody with different skills.
everyone basically used their strengths to help out and just work together. So.
And that's how we kind of knew who to help when we.
Yeah.
Yeah.
That came together quite seamlessly. Oh no.
How long did it take us to decide on that?
One thing I think that what appears to be a really big theme of what you're proposing is basically an enclosed system, trying to recycle as much as you can, trying to minimize losses because resources are scarce, which is really cool, and obviously I think that would be necessary on Mars. We felt there was also another opportunity there with your when you're trying to kind of refrigerant to condensate the water. That could be tied with a heating system, with refrigerant and kind of heat pump type.
Yeah, definitely. Yeah.
Just compressors are very easy to use. But it was really cool that you talked about a lot of things. Though you could go endless ways with this. A thought that I had was in terms of how you put this unit together. One thing I imagine on Mars is to start with, space probably is not a scarce commodity like it is in major centres, and so it is a lot easier to build up. It's definitely less effort to build sideways at the start with, and then when the population comes in, then you do in space or something that you do have to build up. I was curious, how large are you thinking this would be? I'm thinking about how many chickens are you expecting to have? Because I'm thinking in mind things, as time has gone on, we've outlawed battery farm chickens, and when we go to Mars, what are we going to take with us from this world, and what lessons will we take? So, what are your thoughts on that?
So, depending on the crop yield and the amount of fertilizer we can get from the chickens and increase the capacity of it, it could scale from anywhere to 20 to 300 or 400 chickens per year. But this would all depend on the scale that we make it, because the filter alone is 60 meters?
Yeah.
Right.
So it'll be a pretty large scale.
Yeah.
To fit everything in it.
Yeah.
But yeah, it'll all depend on the crop yield and fertilizer and everything.
Per chicken, it's about just around 20 meters squared of field to supply chickens with enough food to sustain themselves.
Yeah. So yeah. And also, everything we hear about some research that you've done, beginning to what NASA's proposed, and again, you're kind of like just picking around the edges, making sure they get the right ballpark.
So, one thing about chicken fertilizer, it is normally, if you just throw it in your garden, nothing else, it will kill the plants because it's too rich for the soils. So that's why we've watered it down and taken it at different times per day, so it just doesn't get too thick, too condensed. It takes too much time. So that's that.
All right.
Thank you.
Is that all the questions? Because
just a couple quick ones from
okay.
me. Just a couple of questions for me really regarding your assumption to infrastructure already on Mars. So I know on this diagram here you've got salt water below ice. Do you know how far roughly that is below Mars' crust, or give assumption with how far you have to hit?
A lot of water on Mars is also it is underground, but it's also above ground as well. So we could just go to a village where we could do this above ground, and then just have the pipe go into below this the water, and that could be done with that. So we wouldn't really have to dig that far.
So they're kind of like oil.
Okay.
Oh yeah, you'll find big pockets of it.
It's not that deep. Like asteroids have hit Mars and exposed ice, so it's not that deep.
And with regards to energy, I know here it says high power radio waves. What type of energy is that in Mars currently?
There is a lot of uranium.
But we were our backstory for it was we were already assuming the colony that already joined, they already had pretty much most things solved.
Yeah.
They just didn't have any sustainable food sources or water sources.
Yeah, and as sustainable food sources should have enough nutrients, and it did not. So this is a way to have a lot of fresh nutrients come in the plants and meat and eggs.
Okay. Great, thanks guys.
All right. Thank you.
We're gonna move on. Yeah.
Yeah, I think it's
Oh. Sorry about this, guys. The projector, which has been fine for 5 years, sounded like it didn't sound very happy, did it? But the next group needs it, so we're going to give it a go, and if it crashes again, we're just going to whip it out. Yeah. Good job, guys.
Yeah.
Well, if it works up here, then the streams. Well, unless you want me to turn the streams to the back. Then we can have more. Okay, wait, okay, but you can do your thing. Hey, Darcy. Darcy, can you go get one more drink? I've ordered it. I'll get charged down with that as well.
I'd now like to introduce the stage the Mars Cellular Group, or with their Mars Cellular Robot.
Hey judges, we have Marcella, sorry, Auckland. My name is Barboy, and I'm from Auckland.
I'm Cairo, I'm from Christchurch.
I'm Jeremiah and I'm from Auckland.
So I did the programming and the electronics. I did the design as well as the presentation.
Oh, I did all the CAD designing and scripted body. Check out the yeah, check it out.
Wait for it.
Excavate samples from a recent meteor strike on Mars lost communications 18 kilometers from their base destination. Hours have turned into days, but still no signs of the group. There is a crucial need for communication, friendly, for Mars, development of humans living on Mars. The next mission coming up is to help the colony to prevent and decrease the chances of getting lost and provide safe passage around Mars.
Right, so this is what's happened to them. This is so what they've done. They've started off at the departure point. They decided to
the group of scientists have decided to move around the canyon. As they came through, they started to lose connection about where that kind of river area meets, but then we lost connection up by that crater. We suspect they're probably around about that crater within like a 20k radius, but we're not too sure.
So the next mission launch is in 27 days.
So, introducing the Marcella communication system. It is a portable communication tower, which is autonomously controlled and adapts to the needs of the Mars colony for communication. So the functions of this is that it has a transportable extender, and it can be used to communicate between areas and bases on Mars, which would be important for like emergency contacts, which would help the Martians that got lost on the previous mission. And then this works through triangularization, which is the signal. Yeah.
So it sends a signal from a master device. So whoever's trying to send a message, it sends it through to a rover. That rover either does a direct path straight to the receiver. It does that by amplifying the signal to extend it over about double the range of one transceiver would be able to do. This can also be done with triangulation, which means that it will go through one rover and map out the correct path that will give a most direct route straight to the receiver.
So the purpose of our rover is so that it can act as like an emergency contact thing, so that scientists that do go out to explore Mars, if they get lost, they can contact the base and ask for help. It can also be used for like constructions, to request for materials. If the scientists were to get lost, it can also locate where they are accurately and help find them. It's also quite small and compact, opposed to towers, so it will make it easier to transport it to Mars. And yeah.
So the full-scale version of this, which will be sent up in the next mission in 27 days, will have a range of about 70 kilometers. It will be taken up, we'll probably have about 3 of them on the mission, depending on how many people we have to send up, but the weight's about 500 kgs. So it will be powered fully by solar power as well as some regenerative movement through the wheels. This will be done with the foils inside of the motor. They will be regenerating power as they get spun. So this will let it to go at about a 1 kilometer an hour speed. This is pretty slow due to, well, it doesn't have to move too fast as it's moving with the signals, and also it means it doesn't interrupt signals too bad. These signals will be generally around a 4 megabits per second bandwidth. This means that it's not going to have too many people on board, but it supplies enough and a strong connection to be able to communicate back with the base for whatever you need to talk about.
So for the design, we've used 3D printing and laser cutting. So for this structure, we've 3D printed the body really and the rims, or the wheels, sorry. So I've done 3 different types of wheels, and our final design had natural suspension, which are on now. And for the chassis and some other parts with laser cut because it was quicker to make.
So the benefits of this to the colony would be like how we said in the previous slides, it would accurately find the location of the lost Martians, and it could also, sort out a rescue mission to find them and bring them back to the base. Yeah, and it also makes Mars a safer and more connected place for expansion in the future.
So some future improvements would be regenerative energy. So when the vehicle moves, it spins a generator and it creates energy for the bot. Also increasing the fleet size, so getting more robots, mapping out terrain, and autonomous operations. So just the robot driving by itself.
So this will be sent up in 27 days on the launch, depending on what the weather conditions are, but hopefully we should get about 3 or 4 of them on board. This means that we'll be sending these out to try and find the lost scientists, and hopefully we bring them back safe. Thanks, guys.
Just before we get off, I'd like to thank the judges for listening and to Clark for helping set this up and everyone else. Thank you. Are there any questions from the judges?
I've got one. Did you guys end up getting it running? Can it move?
Well, we did have it running to about like 2 hours ago. It was running this morning, but unfortunately we have fried one of the motor drivers, so that means we can't actually drive it.
Did you guys get any footage of it?
No, we didn't.
We went out to find the motor drivers, but none of the J cars happened to have it today. Yeah.
What about the communication aspect? Is there any that in terms of how you send text to it or anything like that?
Yeah, so we had a slight disaster. So our transceiver, they run on 3.3 volt communication, but we only have 5 volt supply, which means we would have to make up some dividers, but we don't have the resources available for that right now.
I guess for me, maybe cover that in the scenario is one, I guess, alternative to a rover is just to bounce the signal back to Earth and then back again, and maybe that takes, I don't know, 8 to 10 minutes each way, but is there something that this solves that would that kind of scenario can't happen? Is it a Martian weather, or is there some reason that instead of a rover you could actually just use Earth as your communication sort of point?
Yeah, the main benefit of this is because it's quite precise. So if you're trying to bounce the signal all the way back to Earth and then back, you have to really pinpoint the exact location to send the signal, and that would be working within like probably a 10,000th of a degree, which you had to use probably, I don't even know if they're built yet.
Also, according to the resource, it was a lot longer the time to communicate with Earth. I think it was like 3 to 5 hours. I think it was.
Any more?
I've got a few questions. Yeah, I really like the idea of the football comments like system that really the safety of astronauts up in Mars. One question I have is how's this rover controlled? Would it be controlled at the base at Mars and then some like astronauts building it around, or is this more like a radio or radar like it can kind of show you and it guides it by itself?
So basically, for like a future improvement, we're gonna come up with like a way of contacting the rover. So between like 2 people like contacting, it would like go in the middle to like enhance the signal, so that they can talk with each other.
You could also develop a remote control to work with the rover to control it from the base or from the astronauts.
As well as in high intensity environments with many different people around, the triangulation comes into great benefit as you can direct the signals depending on the rover's destination at any one time. So you don't actually have to move to the places, you can just bounce off the ones that are already there.
A couple of site-specific questions for me. You mentioned solar power is going to be the major source of energy. What sort of daylight hours do you get on Mars?
Well, it's shorter than here, but yeah, so we'll have highly efficient solar power panels. So that will be charging up quite a big battery that will be used for most of the time. But yeah, it will also be using quite a bit of regenerative power. So it doesn't use all that much power to start with. So we should be running all right.
And in terms of some of the materials of the rover itself, being in that climate, what would you propose those materials are?
Well, aluminium would probably be a good fit, but also for like internal things, we would have to use a quite corrosive, not corrosive material for the outside, as the dust forms that will cause a whole bunch of rust and that kind of thing. Yeah.
I thought you guys did a really good job of just the scenario of the fun creating quite minutes of all done there. I'm curious, sorry, as a strategy, I don't know too much about telecoms and methods out there. So it's the way of communication is it like kind of like using like so kind of last up one.
Yeah.
Is there any specific reason why like you would use radio waves or kind of like more, I guess, ancient terms, which eventually what I understand go through the
For this version, it is on radio waves, but for like high intensity areas, when the colonies start to adapt into larger areas, will most likely be moving through to cellular like technologies, which allow for many different slave devices to hook up to it.
Yeah, it's a lot more efficient and take something small up rather than taking big metal rods for the cell towers and stuff, and not having to use as many because you're not going to be on the whole of Mars yet since population's got low. It's more efficient.
So, thank you.
Thank you.
Well, we'll turn it on and see what happens.
Okay.
Really hope this works. Added some nice little animations to our slideshow. Keep you interested. But if it doesn't, it's fine.
Yeah.
Okay. Okay. So I'm Darcy, Boob,
and I'm Teekman again.
So we're the Dominators because we're going to dominate. Well, hopefully anyway. We first met at Grapple. We'd never really talked before, and yeah, we just wanted to work together and design something cool. So we'll just get right into it. So hold on. Basically, what we've, when you go to Mars, what resources are we going to be low on, right? Pretty much everything, But energy is something that we really, really, really need. And it's difficult to come by energy on Mars, okay? Solar energy is only about 60% as effective as solar energy on Earth. So we had to come up and think of a way to kind of have a better option than just solar energy alone. So, continue. Our aim was just to make living on Mars more sustainable, make it easier, and really we want to make it more than just Mars, We want to use this technology across a bunch of different sectors and a bunch of different environments, and even on Earth, because it has the potential to do very well in many different places. I'll get to that in a second. Okay. So we're using culture modules in our devices. Has anyone ever heard of them? Culture modules. Okay. So basically, they're used in mini fridges to actually cool down everything. And, that's pretty much all they're used for. And people don't really think about the other things that they can do. And they can have the inverse effect of running a charge to them. If you place cool on one side and hot on the other, it can actually generate a current. A small current, but a usable current. And that's what we want to make use of. And it's a funny physics principle. It's called the Seebeck. It's Seebeck's law, right? And I'll show you how it works in a bit. So we want to implement these into Mars, like I said, and different spots like Nepal, where it's really cold outside, and places where there's maybe not a lot of sunlight, perhaps the International Space Station, where there's plenty of sunlight, but it's really cold outside. And that can definitely help us generate a current. Seebeck effect. Basically, I might actually draw it on the whiteboard. Is that all good? Can I draw it on the whiteboard? Yeah. Okay. When you have a wire, there's a wire, yeah, and you apply heat to one side, it's gonna make the electrons go all crazy and wild. And basically what that does is it makes them spread out a whole bunch, so they're very spread out, and so the electron density is very low over here. And making it cool on this side, my little ice cube, basically makes the electron density much denser over here. And so there is your potential difference. And there's your voltage. That's where the voltage comes from. And so now it's going to go, the electricity is going to travel from positive and negative end, conventional current, all right? And there's your current. And so basically, when you have another wire on the other side to complete the circuit, it's got to be of a different resistance. That way, when the heat is applied and all the electrons are going crazy over here, and the electrons are very close together over here, the current is going to flow in the opposite direction, just not as strong because the resistance may be greater. And that way, there will be an overall current traveling in a certain way. So if this side is greater than this, it will travel around that way. Anyways, why don't we show you our design? So basically, we want to use these in a bunch of different sectors. So we've come up with a way to make them modular and make them stick together like bricks, so that we can then build stuff out of it. So that's how they stick together right now. And, you can have a look at them. Yeah. You can snap off the front plate to have a look at what's inside. It's quite simple. Basically, it's a poucher module, just connected in a series circuit. It's very simple, which is why it's quite surprising that it hasn't really been researched all that much or used all that much. It would be cool if we changed that, eh? Okay. So this is where we're going to show you our little demonstration of how it works. Does everyone want to just come up and have a look at this over here, if you don't mind? Need some of your interaction. So
we need to find a special person to flip the switch.
Basically, we've got a kind of representation of Mars on here, and here's our habitat, right? Okay, it's not the best looking, but it's a designing habitat. So we've put some lights in here just to show how this can work. So I'm gonna put some cold stuff on the top, hot stuff on the bottom.
Yeah. If someone wants to come over at the moment, just to prove that we're not using batteries, you might hold your horse. Come on.
Oh yeah.
Just to prove that we're not using the battery, someone come turn on the switch, and
okay.
Yep.
No light.
And as you can see, there's no light.
Oh, it's okay. So why don't we try it out? I'll show you just what we're talking about. It's gonna lie.
You gotta believe.
We go. Yeah, let's go. Okay, go. Go.
Yeah.
If we just give this a minute to kind of hook up, we'll see that it will be able to power this. And we'll show you actually with a voltmeter that it is producing a current. And, you know, a pretty significant voltage, I would say. You know, you wouldn't expect these things to produce that big of a voltage, but they do. I'll tell you about that in a second. I'll explain everything.
So we can see here, we stick that one in there. Hopefully if it works. I think it's flat.
Ah, it's the one that we're using for.
I don't know. Got you on.
Sorry.
It's normal grapple activities. Everything being flat.
Right, in the meantime, what we can do is, does someone want to come over and thread switch again? Alright.
It's just not a bit. It was working before. We were good.
on.
Oh yeah, I did it off again. You should live like Grapple.
Well, maybe.
Yeah, live like a thing pop out.
Yeah.
We have video proof of it working. Keep that.
No.
Did you find it?
Where's it? Isn't it?
Okay, there you go.
The voltmeter go. Oh, we need a voltmeter. Yeah, that's what classes.
Remember, there's a video of the RGB signal, just a regular light. Wait, check if it's.
Yeah, we need a.
Yeah, we actually really want
So if you have a video,
Let's watch the video. Yeah, now. A bit lame. Just a small. No, it's fine.
have you got an iPhone?
Oh, I'll pass it up.
You got an iPhone?
Yeah.
We can use one of the other ones. Are you right? Anyone's going to see your stuff? So please. Jesse, you're on the video.
We made it. We're on TV.
There we go. This is us taking a light off. Checking if it works. There's another video as well.
We could do it again with other ones.
Yeah.
If we.
Yeah.
It'll be a bit jank, but it should work.
Next video.
2 minutes, guys.
This isn't us talking.
Okay, so that's using ice.
They've been asking questions.
This is us using ice with the prototype. There you can see we got 1.74 volts.
And that was just from one of the units. And because we put them in series, they'll stack up. And you actually get a usable voltage.
And I believe after that, we got a video of us using it in the dark. We saw.
When we stack the Peltier modules in parallel, you can.
Here it is.
Yeah.
Yeah. This is us getting all excited. and Tico notices the LED
Yeah.
jump off. It's it's a real shame because it turns the whole strip on. It can turn the whole strip on, and you can.
What we should do now, there are good questions.
Yeah, yeah.
We just need volume.
Bruce, I've one question. You guys keep going well, but the this really relies on permanent temperature differential to really get the most of it. What is that differential on Mars? What's your heat? What's your cold?
Right. Okay, so this is actually, we want to use this to recycle energy in a habitat.
Just being more efficient in general.
Yep. Our idea of, when we were going into this was that humans already have energy on Mars. It's just we want to have a more sustainable way of having it, So basically, the inside of a habitat has got to be like 30 degrees Celsius, room temperature for humans, right? And the outside is on average negative 60 degrees. So that temperature difference is what will create the carbon.
And even the highest temperature that it can get on Mars is approximately 20 degrees Celsius.
With in the nighttime dropping to lows of around 150. I mean negative 150.
How sustainable is the Peltier? Why isn't it been done before? What are the inefficiencies or restrictions?
Well, there hasn't been that many use cases for it like on Earth, except for things like mini fridges and stuff like that. So yeah, it's not that efficient, but that's because not a lot of research has been put into it. But yeah.
The thing is, like, it can obviously be developed further, right? If we think back to 40 years ago or 50 years ago when computers were being developed, they weren't very efficient. But these devices can be worked on and probably improved greatly.
Yeah.
And maybe they're not as efficient on Earth because we don't have a huge temperature differential when we're looking at, habitats on Earth. But on Mars, it's always going to be pretty significant enough to be able to power something like lights. Which is it's what we're going for. And like I said earlier, besides that, we want to aim for just improving general technology. Like as a whole, I feel like this technology is able to improve every single one of the products in this room. It's like we have two rovers, right? If you put this next to an engine on a rover or anything that emits some kind of heat as a byproduct, it's an easy way to just recycle a little bit of energy, on Mars. And so there's so many ways that this can be used, I think. And that's what's so special about this device. I think that's really what we're going for. We want to just make technology more efficient. Because everything, a large majority of technology has heat emitted as a byproduct that we don't want. But this can make it more efficient.
And especially with here on Earth, like there's not that much need to like save all of the energy because like we can just burn more trees. But like when you're on Mars, you've got to like conserve all your resources. And so.
Okay, so there's something wrong with the circuit over here, but if we connect this directly to an LED, we can see that it does cause it, before it burnt out, it did cause it to turn on for a split second.
It's enough to burn out the LED.
Yeah. Can we just connect it, detach it and connect it directly?
I think the switch may have died because we were fiddling with it last night.
We got scissors.
Your solder, yeah. Bolts. It's just full of them. Okay. See if this works.
Does the materials required to make this, the only thing, what's special about the layers in between is it just that it's metal and having a temperature, or it's something special that required?
No, no. We don't actually want to use plastic on a real thing, and really I think the best option would just be replacing these with aluminum, so it can survive the conditions on Mars. And aluminum is real light, so it's easier to get to space. And then obviously placing some sealing stuff so it doesn't conduct.
And all the components of the Peltier device can be created from resources gathered from the soil within Mars. So mostly, aluminium and other silicon like that are obtainable from the soil.
And it just has so many use cases, just even.
There we go. Light up the candles a bit. They are aluminum.
I think maybe the LED strip died.
Bill, all right, is there anything else?
I'm going to say that often in engineering we talk about elegant solutions, which is something that's conceptually quite simple, but sound. And I think this is what you're describing here is really elegant, talking about optimizing efficiency, and I think that's really good, and that's the heart of engineering. So well done. I'm sorry you couldn't get it working there.
Yeah.
I saw your video.
To you guys.
The nature of the beast, I'm afraid. The idea is the easy bit. Sometimes the implementation is.
Working just it's a shame. But there's just so many use cases. Like as Yuving was saying with the chicken one, you've got a byproduct of heat. You can use it there. It could be an emergency backup if you're out on a spacewalk or whatever. The human body still needs heat. So you could still capture some of that heat that would just be radiated out. Maybe it was. No, actually, no. It was not. The next group gets a wet table.
Yo, do you remember the ball?
It was making. Hey, Dave. Can we just your laptop?
Well, while they're sorting that out, I guess we can introduce ourselves a bit. Our group name is INH, which stands for insert name here. Yeah, well. So our project, actually first off, before I start, apologize in advance, just like a lot of the other stuff in here, the batteries ran out. So we will not be able to have a demonstration, but we will do our best. So introductions. My name is Dominic. I did a lot of the CAD work and most of the 3D printing, and I also did some of the most of the suspension designing on this project.
I'm Paul with Carton. Yeah, what's up, this anyways, I'm Carlos Curtin. I'm from Hamilton, and I am the robotics. I designed the robotic part and also helped with the coding of it.
I'm Aaron Gutteridge, and I basically got all the drawings and stuff from the other people, and I was able to like convert them into either 3D models to send off to Dom for 3D printing, or into just regular like sketches just for laser cutting.
I mainly just worked on the original software, and I wrote the code for the stuff.
I'm Big. I'm from Brooklyn, and I worked on most of the drawings and the PowerPoint design.
So we're 5 out of 10 colonists that will be joining a group of 50 colonists already on Mars that have been there for 5 years. So it's very, very early stages. Very early stages. This drone is called Rocky. They've named it Rocky. It's the model name is ROCKed, Remote Operated Construction Drone. Our story is that most of other supplies that are needed have already been designed. For instance, we've got communications, we've got recyclables, we've got electricity recyclers as well. And so most of the other problems that have been instantly needed to be fixed has already been fixed. We've carrying on. This is a multi-purpose drone. It is a drone in the later sense. In the early days, like when we've arrived, it is remotely operated. It has interchangeable modules on the core gripper, as suggested. It will use electromagnets in a full-scale drone from there as well. We've also designed it that as more of these drones are incorporated into the colony, they would form a hive mind and be able to autonomously build and destroy buildings and make repairs, similar to the microbots from Big Hero 6. But until that happens, it is a workhorse. It is designed to be remote controlled by an operator, keeping them out of harm's way and allowing them to also be much more efficient. And this is also 1/4 of the scale that we built. In total, it would be. Oh, let me find my spot. Sorry. I can't. Yeah, it would be over a meter long and 3/4 of a meter wide, and the materials would be similar to that of rovers already on Mars, aluminium alloys, all that kind of stuff, to ensure that it doesn't rust and deteriorate over time too fast. Yeah, so that's most of the story. Actually, carrying on. The modules at the end, we came up with 3 designs. The claw that you see here. We also came up with the idea of a drill and a saw blade, but we weren't able to print them off properly.
Demonstrate how like uses the
yeah, go ahead.
So basically, like pretend the robot's working, like, and then. Well, there would be another bit here, but it's like not enough time, so like detach its head there, which uses magnets, and then it'll just move on to here, grab this, and then move it up like that. Uses magnets and it also uses metals screws that's able to transfer the electrical current to the drill or whatever the head is. Huh?
Yeah. So yeah, basically with these as well, so we have this end, which originally was always supposed to like stay on this end, and then attached by magnets, and pretty much all the modules are made with this design. So they'd have like same sort of end where they could clip together, and then be able to perform just its regular action. And then that's also when I came up with the little pin thingy at the back, so when it's not using it, just slots it there.
Yeah, so any questions?
Talk me through a bit about the design development. It actually looks like how did you get to that for that model? And then you've got the tracks on the front.
This actually tracks on the back.
Tracks on the back.
Tracks on the back. Sorry.
Yeah.
Also, so the design elements. If we go back a few slides to the original drawings, we were just talking, and I found inspiration from the new Avatar movie, where they have these the same concept really, and so we drew inspiration from those, and then beyond that, this fella Carlos, he managed to create the robot arm, controlled by hand movements, at his house, and so we just used that arm, put it on top. We built a very simple, we built a very simple suspension system as proof of concept. If given resources and time, it would definitely be adjusted to suit Mars's gravity and terrain, much better than it would work here.
I've got kind of a request. While the other judges ask their questions to you guys, I'd love to see like the slideshow. I can't really see from my point, and there's lots of words that I want to read. So other judges can go ahead, but I just like to have a look at all the slideshows if you want to go through them.
So I've got a question. Can you help me understand what this will do? So it's construction.
It's so multi-purpose. So in the early days, in the beginning, it will be able to do anything. It's got a semi-loading zone in the front here. It can also be filled up with solar panels to keep it charged. So it's that loading zone will then be able to, the tool will be able to pick up supplies, put it into the loading zone, transport it to and fro. And this could include on farms as well. This could include building and construction. It can include mining. It can all those like basic hard labor that would have to be completed. It would be able to do much faster and stronger.
And also with it as well, another thing is that we can have some areas of Mars, even currently it's too dangerous, just to send in a human because people are expensive, whereas robots not really as much. You can afford to lose a robot instead of a human. You not only you can send them out to go places where we probably can't send a human, but it's the fact that you can in way future designs we wanted to integrate into the hive mind system is the fact that we can get the whole thing done automatically, basically like how 3D printer works. So that means not only we can keep our people safe, but then we also get to have less people that's primarily focused, or less people that need to focus on building or construction. So then instead, they can look into maybe more something like research in a way.
Is there any reason for limiting it to 1 meter long? Can there be?
It can increase in size. It can increase in size, yeah, it will decrease as well. But it's a case of sustainability. It's also a case of limited resources, and also the fact that we don't want it to be in the way. It also is completely covered in sensors, from atmospheric moisture to ground moisture to atmospheric pressure to motion sensors to ultrasonic sensors. So it also has a complete range of data collecting systems, which is separate to the functioning systems, so that if one or other fails, it doesn't affect the whole robot. But the size ultimately was based on it being multiple small ones, and if hundreds of them are working together, then it will be able to build and demolish things easier in less space.
Also, another feature we were thinking about adding as well was if we were able to equip each of these robots with like some form of camera, and in that way you can have it so sure you might not have people remotely operating these drones, but you could have like probably a couple people maybe on like computer monitors or like on a VR, just like remotely like observing and seeing like where they're at or what they're doing. So if they ever need to like do some troubleshooting or data collecting, or if they just want to just have a geese, then they can do that.
And another thing, like the 3D printer analogy that was used before, its location needs to be individually known at all times. So originally we were going to say it had its own radio waves, receiver and sender. It still does, but we can also incorporate Marcella's technology as well. when we later found out about it, to increase range and ability, and so that drones will also be able to explore further.
I really like the map for it, but it's the swap tools that in terms of just fleshing that out as an idea, the idea of storage. I think that's just really practical. One question I had was there any particular reason why you chose it to have wheels and tracks? Was there other modes of
it could be. It was an example to show that it can have both.
Yep.
It can have both wheels, both tracks. Like I said, with more time, we'd be able to design something that would suit Mars better. Wheels used in New Zealand and tracks in Earth as well as tracks. Wheels can be easier to get over boulders in some cases, but tracks can also have more traction in other times and places as well. So it didn't really matter. It was just proof of concept, to be honest.
I mean, in terms of like if construction we're looking at it, be really cool. One idea that's really point I would be just something on legs, kind of like the monster robotics kind of dog that I've got. Because often in construction, sometimes you've got it in height, so you get a scan ladder, platform, something like that, as opposed to just being able to work on the ground and having legs.
And going on from that, originally we also had the idea of having land-based and then also air-based drones that flew and were able to reach those heights, like you were saying. And we did mention water-based, but Mars doesn't have too many lakes or rivers to worry about, at least in this stage and in early developments of robots.
Primarily focusing on the land base for the moment, and then as time goes on, for when we get more terraforming done on Mars, which I'm assuming that we will, is that we will then be able to look into those other options as well.
You've got a really cool behind you, and it's some information I think I've glanced up there that some information up there which you guys haven't actually verbalized yet. I'm gonna if you don't mind, I'd love you to maybe take a stroll. Because there's some lots of you've got the points up there that you haven't actually mentioned, so I'd be quite curious that you've done the work.
Yes.
Curious that you see it.
Well then, one thing we also had was smaller arm at the very front to organise the loading bay area. So the large arm can worry about stuff, dropping it down and then just going, while the smaller arm organised in such a way that can increase the efficiency. Like I said earlier, hive system, multiple robots. Mars, obviously, very dusty, red dust rock, and so that can mess up with components and mess up with all sorts of electronics or whatever power system that would be available on Mars. And so we would also have to design around that as well. Carrying on. Code, this guy's expertise. It really depends on the size as well, though, and what motors and what we have available. I don't know what you've set up for this one.
So currently the code that's set up, if the battery was working, could use a keyboard similar to this one attached to a computer, and you can use the wireless technology to interact with the robot to send it commands to do stuff. So this will be during the early phases of the Mars thing, where the robots are still using it. And the other option could include like controllers that may provide a better feeling for the another.
What were you able to do with your code that you've done? It's
So currently, with like early HD can control the go forwards, whatnot. And with the other content, various buttons, you can control each joint on the robotic arm, and you control like how they move and whatnot, and control gripping, rotation, and
So only question for me, have you got an assisted to make it working?
We did get it working briefly.
Did we get any footage?
We got it. Well, we
have so we just have it of just like
thing just spinning around?
We've got the arm separate, spinning. But other than that, no, really said. We would have the policy, so showing you guys, but.
Hey guys, I got a request here.
You did.
Possible we out of the power supply. Actually getting low.
We do that.
That's a good question. Oh yeah, this is a great feature. Just open it up.
Yeah.
Yeah.
Unless we had a soldering.
Alright, you got a challenge?
While that's going on, maybe for a focus point, the particular drone really around horizontal infrastructure. I can imagine building canal, because obviously it's not very tall, like going up, but it could build canals, pipeways, electrical communication lines, that kind of thing. That's sort of, to me, in my mind, seems like the value of this thing, that could be to build these kind of very long parts that, when sort of going large distances, which again is where humans going long distances work in space, is a bad idea of Mars. Any comment on that around how you think that would be suitable?
I think that sounds pretty good.
Yeah. Like we said earlier, it's the early stages of Mars, and so you're not really focusing on vertical building like they are in China right now in New Zealand. And so it would definitely be used for the lower to ground stuff and the shorter buildings and the long distances and travels and all that kind of stuff that would allow humans to focus on data collecting and exploration rather than actually building.
What type of power? How are you planning on like power in the future? Is it like batteries?
Yes, similar to the rovers already built. There were multiple discussions over different ways, but the most renewable way is definitely battery powered and solar powered. At this stage, of course, the technology could increase.
Do you think do like what's the
Second, sorry?
Endurance?
Endurance? No, because it varies greatly on what sort of motors would be used and what the structure would be made out of and all that sort of things. And so it's not very definite.
Yeah, that's right. Almost there. Oh, no, this is
And also as well, of course, when we end up mass producing this as well, like we'd also, like I personally want to definitely do more improving on the, aesthetics of it as well. Because like, of course, it's good to get something functional, but if we can also get it in a form of a design where it can also look pretty presentable as well.
Looks pretty.
Yeah.
Just a paint job.
Yeah, it's basically all night.
and maybe actually having the sensors there.
Yeah, like fully integrating the sensor and
limited resources.
We're just trying to figure out how to add how.
Mistakes. But is there any reason why there's two different types of wheels?
Like I said, proof of concept. So I said earlier, proof of concept just to show that it's different types. And in all honesty, the other set of tracks that we were going to use, I accidentally seized up with glue. So I figured we were just like proof of concept. Let's just throw some wheels on just to show that it could work as well. It also shows how well it could work in Earth as well as Mars, if ever was continued.
Do you want to?
Well, that's the upward sensor.
What's that? Take it.
What's on the panel?
Tracks 3D printed, and then these plastic we found courtesy of Pinto giving me a box. I just looked through it and found those. So, yeah, well, it's mostly the beams, but the springs as well. So I wanted to get shock absorbers, but for some reason, Jacob didn't have any. And so I just attached springs after prototyping all night, trying to figure out a way to make shock absorbers. So I just stuck springs on there. I was going to use the Thingiverse file for suspension, but I just designed this from the top of my head. with what we've got. It is just the springs and the wood beams holding it up really.
Also with the springs as well, like it's the fact that we're still able to show the proof of concept. Well, just like, hey, yeah, we're going to have suspension here.
It is plateau. Oh, there's another way.
Open surgery.
What time should we?
This is a live surgery.
Looking into some few things. I think
It's like playing operation.
I think we're forfeiting the motors to use the arm at this stage.
Why is it?
We can see that judgment there. Even go.
Yeah, it's
Yeah.
Let's know we don't hear.
If we had your attention for a couple of minutes because we think we fixed our issue. It was just a faulty connection. We can talk.
All we're going to do, Judge, is we'll listen to the room on the side of it, and I'll leave you to it. But,
yeah.
yeah.